We indicated earlier that it is not possible to determine the activity coefficients of individual ions in solution because no experimental technique can isolate cations from anions. Hence, we must rely on the mean activity coefficients of the ions formed by dissolution of a given electrolyte to obtain the chemical potential of these solvated ions. Mean activity coefficients for ions in solutions are either determined experimentally using, for instance, electrochemical methods, or estimated on the basis of a model proposed by Debye and Huckel in 1923. Considering the balance between Coulombic forces that tend to repel like charges and attract unlike charges, and thermal motion that tends to disrupt any ordering of these charges in a crystal-like structure, Debye and Huckel postulated that each ion in solution is surrounded by an oppositely charged ionic cloud or atmosphere. The preponderance for any ions in solution to be surrounded by ions of unlike charge implies that ions have a lower energy in solution than if they were in an ideal neutral solution. The attraction between an ion and its associated ionic atmosphere explains why the activity coefficient of ions is less than 1. The larger the concentration of ions in solution, the stronger the attraction between any given ion and its surrounding ionic cloud, the lower its activity coefficient. Two factors control the strength of the Coulombic attraction between an ion and its cloud: the ion's own charge and the concentration of charges in the surrounding cloud. To describe the concentration of charges in the surrounding cloud, Debye and Huckel define the ionic strength of a solution, a quantity which we will write as I. The ionic strength is a quantity that reflects both the concentration, here the molalities, B sub I, as well as the magnitude of the charge of each ion in solution. Note that the square of the charge of each ion appears in the expression for the ionic strength. Note also that the ionic strength is a unitless property of a solution. Debye and Huckel propose that the logarithm base 10 of the mean activity coefficient for the ions of an electrolyte is expressed as minus A times the absolute value of the product of the ionic charges of the electrolyte times the square root of the ionic strength. A is a constant whose value is 0.509 for water at 25 degrees Celsius. This equation is known as the Debye-Huckel limiting law, as it is expected to be valid only in the limit of very low ionic strength. As expected, the larger the ionic strength, the more negative the logarithm of gamma plus minus, the smaller the activity coefficient. On the next slide, we will examine an example of calculation of the mean activity coefficient.